Well, welcome to this online revision session for AQA FP3, in which we're looking at the January 2010 question 8 on polar coordinates. Well, you can see we're given here the polar equation of the curve r equals 4 times 1 minus sine theta between 0 and 2 pi. And we also have this line L drawn across, which is the line r sine theta equals 1. And in the first part we have to find these points of intersection, just where in fact this line touches the curve. And then in the second part we then have to find an area of this shaded region R, which we'll come to later. Quite a long question here, 16 marks at stake. So, part 1 of this question, trying to find the coordinate of P and then the coordinate of Q. Well, we're given the equation of the curve and the equation of the line, so we need to find the solution to these two simultaneously. And we can either eliminate R or we can eliminate theta, so sine theta from the expression. Decision is yours as to which one you go for. Okay. I think I'll go for eliminating the sine theta. So if we've got sine theta in here, so sine theta equals 1 over r, so we can substitute 1 over r into the result. So we get r equals 4 lots of 1 minus 1 over r. If we then multiply through by r, we're going to get r squared equals 4 times r minus 1. And so rearranging this, we get a quadratic, which gives us r squared minus 4r minus 4 equals 0. And we can see this is a repeated root of r minus 2 squared as the factor equals 0. And so our value of r is going to be equal to 2. So then to find the value of sine of theta, we can see that r sine theta equals 1, or sine theta equals 1 over r. So therefore sine theta must equal a half. And so what values of theta equal a half? Well, we know theta must therefore be equal to pi by 6, 30 degrees. That's one value. And the next value round, remember in the symmetry of the sine graph about pi by 2, will give you an answer of 5 pi by 6. And that will be the value which will give us the second coordinate that we require of Q. And so we can say that the coordinate of P is going to be 2 pi by 6, and the coordinate of Q is going to be 2 5 pi by 6. So we had 5 marks for this. Well, certainly get 1 mark for obtaining an appropriate equation up at the beginning, and then obtaining a quadratic that we could then solve, give us a mark, and then working through appropriately will give us a 3rd mark. And then for obtaining correct values for the angles, and then these 2 points will then give you your final 2 marks. Okay, so reasonably straightforward on that first part. So now we've got the coordinates of these 2 points here and here, remembering that from O here we know that the angle coming out this way is pi by 6, and by symmetry this is 5 pi by 6. So if we're going to obtain the area that is shaded, what we can do is find the area of this triangle OPQ, and then we can use integration to find the area enclosed between O and P and the curve coming back round. Okay, and obviously we've got two of those by symmetry, and if we subtract those two from the area of the triangle OPQ, that will leave us with the shaded region R. Okay, so what can we do? Well, the first thing we can do is to calculate the area of the triangle OPQ. Now we know that the area of a triangle is half the base times the height, or we can use the fact that it's going to be a half multiplied by 2 multiplied by times 2 times the sine of the angle between OP and OQ. So we're using a half AB sine theta, finding the area of the triangle. So it's a half times A, which is OP, which is 2, times OQ, which is 2, times the sine of the angle. Well, if the angle of Q back this way is pi by 6, and similarly pi by 6 over on this side, taking that away from pi, that gives us the sine of 2 pi over 3. And the sine of 2 pi over 3 is root 3 over 2, and so the half times 2 times 2 times root 3 over 2 leaves you with an area of root 3 for OPQ. And the next thing we need is the area enclosed by OP and the arc OP. So it's the area between OP and arc OP. Now we know that that is given by the formula a half r squared d theta. So our limits will be between the angle from which we start, which is pi by 6, going through to the angle which is going to be pi by 2, because we're going only as far as coming from this point round to O, which is back at pi by 2. Okay, and r squared, well, if we know that r is equal to 4 minus sine theta, we've got to do 4 squared 1 minus sine theta squared d theta. And I need to remember to put the half in for the half r squared. So if we tidy this up, we're going to get 8, the integral pi by 6 to pi by 2. Now we can now square out the 1 minus sine squared, sorry, 1 minus sine theta all squared, which is going to give us 1 minus 2 sine theta, and that should then give us a plus sine squared. But we should know that to integrate sine squared, we need to use a double angle formula identity. And you can see here at the bottom right hand corner of this slide, I've written the fact that we should know that sine squared is a half of 1 minus cos 2 theta. So we can put in here the fact that this is now going to become plus a half minus a half cos 2 theta d theta. Now we can set about integrating this. So we've got our 8 still out the front here, square brackets. You can see we've got a 1 plus a half there, so that's 3 over 2. So that gives us 3 theta over 2 when we integrate 3 over 2. The integral of sine we know is minus cos, so this becomes plus cos twice cos theta. And then the integral of minus cos 2 theta will be minus sine 2 theta over 2, but we've also got the half there, so this will become minus a quarter. Hang on, the sign differentiated is positive, so we've got to change the sign on this, haven't we, because that will give us the, no, I said it right the first time, this is minus, yeah, because the differential of sine is cosine, so to get the negative it would have to be negative there. So this is negative a quarter of sine 2 theta. And we need to evaluate these between pi by 6 and pi by 2. Okay, so what have we got? We're going to get 8. So putting in pi by 2, we're going to get 3 pi by 4. And the cosine of pi by 2, which is 0. And the sine of pi is also 0. So there's no more terms to come from putting the pi by 2 in. Then we've got to do minus substituting in the values of pi by 6. So that's going to become 3 pi over 12. Cosine of pi by 6 is root 3 over 2, so times the 2, that will give us plus root 3. And then we get minus pi by 6 doubled is pi by 3, and the sine of pi by 3 is also root 3 over 2 times the quarter gives us root 3 over 8. And so, tidying that up, we get 3 pi over 4 minus 3 pi over 12. Well, 3 pi over 4 is 9 pi over 12, which gives us 6 pi over 12, which simplifies to pi by 2. Minus the root 3 plus the root 3 over 8. So if we then multiply through by the 8, that gives us 4 pi, and then we get minus 8 root 3 plus a root 3, so that's minus 7 root 3. Okay, so that's the area of these little shaded bits on either side. So to find the area of R, What have we got to do? Well, we want the area of the triangle, which is root 3. So it's the triangle OPQ, and we got to subtract twice the area OP arc OP. So that is going to give us root 3, the area, minus twice 4 pi minus 7 root 3. So we can see if we collect the root 3's together, we've got minus 2 times minus 7 root 3, so that's 14 root 3 plus the other one gives us 15 root 3. And then minus 2 times a 4 pi gives us minus 8 pi. Question sorted. As to where you're going to pick up your 11 marks, well, a method mark for realising that you've got to work out the area of this triangle, and using an appropriate method for calculating the area of the triangle and for obtaining the root 3. So there's one for the statement, one for your method, and one for the accuracy of your answer there, getting the root 3. And then for finding the area of one of these shaded parts, a method mark again at the beginning for using the appropriate formula, a half r squared d theta. And for ending up with this statement as to the integral, you'll get 1 mark, and then simplifying it down to being in terms of cos 2 theta will give you a mark. Obtaining the correct integration will give you a mark. But then substituting in will give you 1 mark, and then for obtaining the correct answer, whether it's 4 pi minus 7 root 3 or the 8 lots of, either expression will do fine there. Then for showing how you're going to then obtain the shaded area that you require, you'll get 1 mark, and then for the final answer you'll get an accuracy mark. 11 marks, a lot of marks on that last question. You must make certain that when you're timing your exam questions that you leave an appropriate amount of time for the longer questions and don't spend too long on the short questions. Hopefully you found the solution to that question helpful. For more work to support your maths revision, please go to the Further Maths Support Programme website.